Hello everybody and welcome to my very first online video recording of a lecture that I was hoping to do with you all in class, but given our recent school closures due to the COVID-19 outbreak, instead of teaching this to you all in class, we're going to learn this together in the comfort of our own homes. So as you all have been made aware, teachers at our school are providing optional assignments to give you all an opportunity to continue learning throughout this break. And so with that being said, the information that I'm going to be covering with you all, the assignment that goes with that will also be optional, meaning that if you are able to complete the assignment, I will be giving you credit for that assignment. But if you, for some reason, cannot complete the assignment, you won't get any credit for it, but it won't count against your grade. So by completing the assignment, it can only benefit your grade, but it will not negatively impact your grade. So with that being said, I am checking my email every day, so you can email me if you have any questions or concerns or need any clarification on the assignment itself. So with that being said, let's go ahead and get started. I'm going to go ahead and adjust my screen now at this time. Okay, perfect. So as you see here, I've actually pulled up our evaluation criteria because, again, this is what we created as a class to determine how to prioritize which species to save that are already endangered or critically endangered. So up to this point, we've covered our content that we've been covering has so far been on criteria 1, which has to deal with protected areas, criteria 2, which is use and trade. Then we skipped ahead and we covered criteria 6, climate change, food webs, natural disasters, habitat fragmentation, and then today I'll be going over closest living relatives for your species. In the future, we'll come back to criteria 3, 4, and 5, so we can wrap up the content surrounding overharvesting, pollution, and habitat loss as well. So let's go ahead and take a look at criteria 10 here, which is closest living relatives, because this specific content is going to focus on taxonomy and a bit of evolutionary biology. So if I go to the learning outcome, which is in a Google slide that I've posted in Google Class as well. Our goal for this is that we're going to make critical connections between a particular species and their closest living relatives by interpreting evolutionary relationships and modeling how their species is classified using the Linnaean system with a phylogenetic tree. So let me go ahead and skip over to Google Class now. So as you can see here, under week 11, you can take a look at those Google slides. And then under classwork, as you see, I've already posted the criteria 10 case study, which is going to have you take a look at closest living relatives for your species, or what that means in general. So essentially, for this assignment, as you see here, you have a Google Doc, which you're going to take a look at to answer particular questions. It also has instructions for the case study as well. Here are the 2 web articles that you'll be referring to answer those questions. And then you also have, let me move it over a bit, the species phylogenetic tree, which you will make a copy of and complete using Google Draw. So I'm going to first start with the case study document, and then I'll finish with the phylogenetic tree. And then, of course, there's just further instruction here. Just like we've been doing this before recently, you'll make a copy of both of those documents, input your information, and then submit your work via Google Class. Okay, so here is the case study Google document. So I've already provided a brief definition of taxonomy, and then the 2 different web topics that you will be looking at. So the first topic is the history of life, looking at patterns, and then the second topic is speciation. So the overall inquiry question for the first topic is, how does evolution lead to the tree of life? And then the second inquiry-based question related to the topic of speciation is, what are species anyways, and how do new ones evolve? So hopefully by the end of reading the information and answering the follow-up questions, you'll have a better understanding of how to actually answer that overall inquiry-based question. So for the first topic, there's 11 questions in total. And then for the second topic, there's only 4 questions, follow-up questions. So there's in total 15 questions that you will be answering as you go through this online reading. So the topics themselves are provided through UC Berkeley. So the information is a little bit of a higher level college text-based reading. So with that being said, the questions that I provided on your case study do go in order with the reading, just to make it easier to chunk that information as you go along. So as we look at the first one, history of life, I'm not going to go through all of it in detail, but just show you what it looks like. So to the left, you have the subtopics of the reading, and then to move forward, you'll just click next and previous. Some parts of this online reading are interactive. So for example, with this diagram here, you can click on certain areas of information to give you a better understanding of how that's visualized. So that's the first topic, history of life, and then the second topic will be on speciation, and then here to the left are the subtopics as well. Now, if you'd like, you can go back to the main page, Evolution 101, and take a look at the other topics UC Berkeley has provided. However, I just chose the 2 specific topics for your case study because I felt like those 2 most aligned with our project and the content we need for our project. So with that being said, after you've answered the follow-up questions, you're going to go ahead and put that information into practice by building a simplified phylogenetic tree for your species using the Linnaean system of classification. So I've actually combined, after you do the readings, you'll understand what the Linnaean system and the phylogenetic system are, and you'll see how I actually combined and simplified both systems so you can complete this model exercise for your species. Now, I've also provided an option as well if for whatever reason you would like to do a completely different exotic species, a species that's not your project focus, you're also more than welcome to do so. So in order to do this, you're going to make a copy of the Google Draw that I've also included in the assignment, and then you're going to input the classification name for each hierarchical category at the top of the tree. Then, as you go along the tree itself, you're going to describe one characteristic that distinguishes the hierarchical category your species falls under. So let me go ahead and show you the Google Draw so you know what I'm talking about here. So as you see here, I've already inputted some information already, starting with the trunk of our tree being the domain itself, which is Eukarya. So specifically for all of our species concerned, we fall under this domain because Eukarya means that all of these species within this particular tree of life have eukaryotic cells. And eukaryotic cells typically have organelles, cell membranes, and nuclei, as well as other things that distinguish this type of cell from, let's say, a prokaryotic cell or a bacterial cell, for example. So with that, as you move along the tree of life here, or your specific phylogenetic tree, each of these nodes or blue circles represents a speciation event or some type of emerging characteristic that makes that specific category unique to itself. So as you can see here, what I noticed with both of our classes is that all the species selected for your project fall under the kingdom Animalia. So under kingdom, I just went ahead and included that identification. And then for that particular characteristic, I just inputted heterotrophic. Because all species that fall within the animal kingdom share that one common characteristic. So all animals are heterotrophic. And that word is a recap from our vocab on FoodWeb. So again, a heterotroph is any type of organism that it has to acquire nutrients or energy from something else. It cannot make it on its own. So with that being said, as you go through the categories, there might be more than one characteristic that falls within that category, but I'm only looking that you include one, just to keep it simple. So let me do a brief example. So let's say, go to the IUCN Red List for your species so you can actually get the taxonomic information. So just for an example, I'm going to say, okay, my species is the Tasmanian devil. So as I scroll down here to taxonomy, is actually going to give me the entire Linnaean classification for my species. So the Linnaean system, in short, classifies species based off of a hierarchy of groupings, starting with like the largest grouping being kingdoms, all the way funneled down to the most specific grouping being the genus and the species. So you start with kingdom, phylum, class, order, family, genus, and then the species itself. So here, and what's also cool about the IUCN is that you can click on these areas and it will actually pull up other species that fall within that category. So that's where you can actually visually see what those relatives are for your species. Now, because genus is the smallest grouping or most specific grouping, those will be the closest living relatives for your species. And then as you further branch out, then those relatives become more and more distant, but are still related to your species in some way. So that's the really cool thing about this exercise, is that at the end of it, you'll realize, well, everything's related to everything. It's just some things are more closely related to things than others, just like first cousins are more closely related than second cousins or third cousins. So to wrap this up, so let's say, okay, I want to see what species or what falls under the genus Sarcophilus. All right, let me go back here. So I'm not seeing, let me refresh it. Okay, so Sarcophilus, only the Tasmanian devil pops up. So I'm curious, because if I wanted to input a characteristic for Sarcophilus, what would I write? Like, what would I input for my tree? So this is where I'm going to do my background research. So Sarcophilus, as it says here, is a genus of carnivorous marsupials, best known for its only living member, the Tasmanian devil. So here, let's say in my phylogenetic tree, for my species, Tasmanian devil, genus Sarcophilus, right here under characteristic, I would write carnivorous marsupial. Now, what I know about the family that it falls under, Dasyuridae, these are marsupial rodents. So I'm going to end here because I've got 10 seconds left to record my video. All the information is in Google Class, so go through it, answer it, complete your tree, turn it in.